Alrighty, so today we're going to do a quick review of some of the tricky stuff having to do with blood typing, both ABO and RH. Okay, so I have to start with a little bit of history. This was all worked out like right around 1900, actually 1900 and 1901, in response to a question that a lot of people had at the time, which was, why is it that when people get transfusions, some of the patients did great and were saved, and some people died? And I think that's actually an excellent question. The ABO blood type is actually genetic, and it was very confusing and difficult to figure out because it's not inherited in Mendelian fashion. So, whereas RH, which we'll talk about later, is. So it was very confusing, and people's understanding of antigens and antibodies uh, really didn't exist in the 1900s. So it was kind of amazing that they were able to work all this out. This chart actually is great. I've shown it to you in class. It shows the 4 different phenotypes for blood type. It shows the genotypes that are possible for each of those phenotypes, the antibodies that those individuals can make, and then on the right-hand side, what happens if you mix the blood types with the other blood types. So if we go through this, it should make some sense. So if you take a person with O blood, that's their phenotype. That's what they express. Their genotype is represented by 2 lowercase i's, and remember that means that they do not encode either A nor B antigens. What that means is that if they are exposed to either A or B, they will make antibodies against them. So if you take a person with O blood and you give them O blood in a transfusion, nothing happens. Obviously, that's the same blood type. So this would be a normal reaction. The blood cells are fine. If you give an O person A blood, the A antigens are foreign to the O person, and the O person will make and produce in higher quantities now the anti-A antibodies. And when you have an antigen-antibody reaction, you see agglutination, which is a fancy word for clumping, and that's what you see here. And this is bad. You don't want your blood cells to clump. If you give an O person B blood, the O person will produce anti-B antibodies, and the blood will agglutinate and it'll clump. That's also bad. If you give an O person AB blood, you could do something a lot quicker, like shoot them, and that would be a lot faster. This is a double whammy. Sorry about that. It's not very funny. They will produce anti-A antibodies and anti-B antibodies, and the blood will clump all over the place. So that's a disaster. What about a person with A blood? If you give an A person O blood, it's fine. And you have to think about why that is. It's because when an O transfusion is given, no new antigens are introduced. So the key with transfusions is you can't give a patient anything that the patient doesn't already have. And an O person doesn't have any antigens to excite the A person's immune system. So you can give A person O blood. You can obviously give A person A blood because that's their blood type. You cannot give B blood because the A person will make anti-B antibodies and the blood will agglutinate, nor can you give the A person AB blood, again, because that B is foreign. A B person can take O blood because there's nothing foreign being introduced, cannot take A blood because A is foreign. B blood is their blood type, and the AB transfusion doesn't work because of the A. The AB people are the universal recipients. We can, I say that just because I'm AB, we can get blood from O people, from A people, from B people, and from AB people because we have both A and B antigens. Nothing is foreign to us. So that's the ticket. You've got to figure out what is foreign, and if you are giving the patient something that they don't already have, they will make antibodies against it. So the universal recipient in the ABO system is AB. The universal donor in the ABO system is type O. Okay, so hopefully that makes a little bit more sense. The RH, the positive or negative, is inherited in Mendelian fashion, and it's actually not inherited on the same chromosome, interestingly enough, as the ABO antigens. If one parent is positive, then the child will be positive. If both parents are negative, that's when the child will be negative. So the only issue of medical concern is when the mother is negative and the father, and therefore the child, is positive. So we're going to look at that right now. So this is the scenario. We have an Rh negative mother, so her blood cells do not carry the Rh antigen, whereas her partner, he has the Rh antigen. It only takes one partner for the baby to be positive, so the baby that she carries is positive. So here's an Rh negative mother carrying an Rh positive fetus, and that's not a problem. She will carry this fetus and not actually see the Rh antigens herself until birth, because that's when there's hemorrhaging involved, and the blood types and the blood of the mother and the baby will mix for the first time. At that point, the woman becomes sensitized, and that's what these little guys represent. She will now make, for the rest of her life, antibodies against the Rh antigen. And the problem now comes if she conceives another Rh positive baby. So in other words, if she has another child, with this guy or some other Rh positive man, now we have a problem because antibodies flow from the mother to the fetus across the placenta. And she is now making antibodies against an antigen that the baby produces on its red blood cells. And there's going to be agglutination, and the fetal blood cells will clump. And this is a fatal combination. In the developing world, this causes miscarriages, used to cause miscarriages obviously here too, but now we have the drug, which is a competitive inhibitor. It actually binds onto the anti-Rh antibody. We can't stop her from making these, but we can give her something that has such a high affinity for those antibodies that they're basically unavailable to attack the fetus's red blood cells. So that's a real quick review of the ABO and Rh antigens, and I hope that was helpful.